Okay, so here we are, Unit 8, Lesson 7. Like I said, this is our last lesson before our quiz tomorrow. So this lesson and all the other ones before it, lessons 1 through 7, will all be on your quiz tomorrow. Okay, so you can expect metric conversions, customary conversions, as well as line plots, which we'll talk about today. So our focus today is to make and analyze line plots. Okay, so first of all, we know make means that we're going to create something. Okay, so we're going to actually plot line plots from a set of data. Analyze means that we're going to think about it and interpret that. What information can we get from that line plot? How can we read it? Okay. So first of all, what is a line plot? Danny, I need you to stop talking, please. Okay, a line plot. This is a picture of a line plot over here. This is the start of a line plot. Okay, the line plot is a way that you can organize data. So if you notice, this line plot is organizing this table of data right here. Okay. A line plot looks at numerical data. So you're plotting numbers, and each dot here that you see represents a number on the chart over there, the table. Okay, so if you look, the total number for cubes is 2 for here. There's the first 2. So what do you think we would label this part of the graph? If we have 2, what is that telling us? The total number of 2 cubes, right? So for this part right here, we would write total for 2 cubes. Okay, so what we're looking at is if you have 2 die and you roll them, the total tosses is going to be 1. So this dot right here represents that 1 toss. Okay, so now looking at the next line on our table, if we have a total of 3 for 2 cubes, how many tosses is that going to be? The table shows us 2. So that's why there are 2 dots above 3. Next number is 4. So if we have a total of 4 for 2 cubes, number of tosses is going to be, so again, you see 2 dots over number 4. So let's complete this line plot. Let's go ahead and make this line plot. We're going to create it. That's part of our focus today. So for the next number, 5, how many dots should we have above number 5? 3. So go ahead and fill that in. 1, 2, 3. Number 6, we should have 5. 1, 2, 3, 4, 5. Okay, go ahead and continue that and see if you can finish that line plot on your own. 1, 0. Okay, so this line plot shows the frequency or how many times the total occurred. Okay, so this is the total number. So picture 2 die, you roll them, and I get a 3 and a 3. What would be my total? 6, because 3 plus 3 is 6. This side is showing us how many times that number came up. Okay, so we know the total of 7 for 2 cubes, maybe a 3 and a 4, or a 6 and a 1, whatever total 7, that total came up 6 different times. So that's what this line plot is showing. Is there another way that you could show this data besides using a line plot? Is there a different type of graph that you could use? Like what? You all said yes. So what were you thinking? What other type of graph could we use? A bar graph, I heard. Okay, so a bar graph would work, right? So what makes a line plot different from a bar graph? And how is one better than the other? Jess? Okay, so we would actually have an axis over here, right? If we had a bar graph, it would be a full rectangle, and we would have numbers over here, like 1, 2, 3, 4, and so on. Do we have that for a line plot? No, this axis is not present. What axis is that, by the way? Excellent, good. This is the Y, this would be the X. Okay, so over here, if we were to make these ordered pairs, be the X and the Y components. Okay, so that Y axis is not present on a line plot. Do we still get the same information? Yes, you can still count the dots. Visually, can you see which one occurred most? Yeah, which one occurred most? 7. We can easily visually represent that by a line plot. Could we do that with the bar graph too? Yes. What happens here? I notice over here, 12 doesn't have any dots above it. What does that mean? How can we interpret that or analyze that data? Jess? Yeah, that total never came up, right? What's the only thing that could equal 12 on 2 dice? 6 and 6, right? That was never rolled in these 30 times that these dice were rolled. That never came up. Okay? So that's why there aren't any dots over there. Represents that that never showed up. Okay? All right, so that was making and analyzing a line plot. Let's look at another one. Go ahead and turn your page. Okay, this one says, for 10 days, Mario measured the amount of food that his cat Toby ate each day. The amounts he recorded are shown in the table to the right. Okay, so these are the totals of food, the amount of food that he ate. This one represents the number of days that he ate that much. Okay, so let's go ahead and create our line plot. What would be our title for our x-axis down here? What are we labeling down there? What's our known? Yeah. Good. Okay, it's the amounts of food. And notice, are they all in the same unit? Yeah, so we could say cups of food Toby the cat ate, right? So that would be our label down there. And we don't have a y-axis for line plots. So do we need to label a y-axis? Nope. If we wanted to make a bar graph, we could label it, and it would be the number of days that he ate that. Okay, so what would be our first tick mark here on our line plot? What's the first number in the data? I kind of covered it up, but what's that first one? 1/4 cups, right? How many times did that occur? How many days? Okay. Keep going. What would be our next one? How many times did that occur? So I'm using X's this time instead of dots. Doesn't matter what you use, as long as you're using the same thing throughout. Okay, go ahead and continue creating that, and let's see if you can do that on your own. Okay, so if we look at our line plot, that would be what we could. Now we could have done, we could have started a little bit lower, like with 1/8, and there would have been 0. And then we could have gone to 1 whole cup, would have been 0. So we could have evened it out so that it fit better. But does that give us a representation of that data? Yeah, that visually shows us how we can take this table and graph that information. Okay, so let's look at some of the questions. For A, what is the total amount of food Toby ate over the 10 days? Can we figure that out? How would we figure that out? Okay, so we convert everything to eighths, so we have similar denominators or same denominators. And then what? Add them all together. Could we multiply? Could we multiply 1/4 times 2? 3/8 times 1, 1/2 times 3, 5/8 times 3, right? You do it that way and add all those together. Okay. If you did that total, you would come up with 5 cups. Okay, so you could either add them all or you can multiply the number of days each occurred by the amount, then add. Okay, a couple different ways you can solve that. Looking at B, what amount of food would Toby get if the total for 10 days was distributed evenly each day? Okay, so if we took that, we would have to move this one over here and this one over here to make it even, right? That would make everyone have 2. So what amount could that be, or would that be? Notice if you look at the fractions, are these going up incrementally? Is this equal to 2/4? No, this is equal to 2/4, right? So if we go to eighths, this would be 2/8, 3/8, 4/8, 5/8, 6/8. So does it go up evenly each time? Yes. So our middle amount, he would get 1/2 cup each day. Okay, because it's going up evenly each time. So if we were to even it out, this one will move over there, that one will move over there, or we can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Where the middle one is would be 1/2, so he'd get 1/2 cup each day. Okay. So tonight you're going to be working with line plots and working on analyzing that data and using that data to answer some questions. Okay.